are going to do differentiation and integration. After looking at the trigonometric identities and properties of differentiation and integration, so here we have to differentiate a function which is pi minus theta in a bracket and getting multiplied with tan inverse pi minus theta. So it is simple, there is a bit simple differentiation, there is nothing complex anything. Okay, so here we are getting that these two are getting multiplied, which means we have to apply the product rule. Okay, so this is u and the second one is v. Okay, so let's write here u is equal to pi minus theta. Okay, and u prime, which is differentiation of u, is -1. Okay, then here is v, tan inverse pi minus theta. Oh, wait for a bit. Yeah, tan inverse pi minus theta. Okay, wait for a bit, I want to make a space for this to write it nicely. Yeah, here. Tan inverse pi minus theta. And if we talk about its differentiation, it will be 1 upon 1 plus square of this. Okay, this thing we had learned in the video of differentiation. Okay, so this is the differentiation of tan inverse pi minus theta. So simply we will apply the product rule which we had learned in O level IGCSE Add Maths and AS level, sorry, not AS level mathematics, I think so. So moving ahead, wait for a bit. Yeah, now we will do dy over d theta is equal to, it will be u v prime plus vu prime. Okay, so u is pi minus theta and v prime is 1 upon 1 plus pi minus theta whole square. That's bracket close, plus tan inverse, I'm writing here tan inverse pi minus theta multiplying with 1. Okay, so this is here. Yeah, so what we have to do, yeah, sorry, that's -1, not +1. Okay, that is -1. So just we are done with this. This is pi minus theta. Okay, 1 upon 1 plus pi minus theta's whole square. Now this minus is multiplied with this, so we will write here minus tan inverse pi minus theta. Wait here, yes, tan inverse, oh, shortage of space, so wait for a bit here. Yeah, I can write it here. Okay, so it will be minus tan pi minus theta. So this part is done here. What did we did? We had analyzed that we have to apply the product rule here, and the u was pi minus theta and v was tan inverse pi minus theta. The differentiation of tan inverse pi minus theta is 1 upon 1 plus the square of pi minus theta. Okay, and the differentiation for u is minus 1. Okay, then our product rule was uv prime plus vu prime. Okay, so we had just simply multiplied that, and we don't do anything, just 0. Negative 1 was multiplying with tan inverse pi minus theta, so we get that negative sign instead of the plus before tan inverse pi minus theta. Just that was really simple. Now the complex thing is this. Okay, we have to integrate this function, and we have to do the definite integrals as we have limits here. Okay, so that is bit interesting thing. So first we have to revise the properties of integration. I'm not going in detail to go in detail like that video, just I will tell you those integrations properties which will be applied in this part. Okay, so first of all we have to know that, sorry, I think, oh sorry, I'm wait, I'm writing the differentiation which I don't need to write because we had done that part. But let me write the differentiation properties also here, so in future it will be easy to refer that. Okay, wait for a bit, give me uh bit some time, so then I can continue the second part. Wait. No, not okay. Still, there is something. OMG. No. Sorry. Okay, now it is bit okay. OMG. I think leave this, okay? Sorry, I wasted your time, so sorry. Yeah, just I have to do one thing, that remove this. Sorry, I don't need to remove this, okay? Sorry. I blundered it, okay? I wasted your time, okay? So now I have to do this integration. First of all, I will tell you that properties which we will apply in this part. Okay, so I'm telling you two things. Okay, these two things will be enough to do this question, but I'm telling that this part will be in detail. Okay, so let's start. Let me share those properties. So if I talk about this, we have to know by part method for this. By part method is, if we have integral, it is uv prime is equal to, we can write this as uv minus integral u prime v. Okay, we will apply this, and the second thing we will apply is integral 1 upon 1 plus x square is equal to tan inverse x. Okay, so these two things we will apply in this part. So we have to know these two things for this part. So now we are going to do this question. First of all, I will not do this directly. So instead of pi minus theta, I can substitute it with a. Okay, pi minus theta is equal to a. Okay, so when I did this, so I have to change the limits according to this, as our variable has been changed. The this was a variable for the values, these values are for that variable. Now our variable has been changed. Now our variable is a, so our limits can be changed. Okay, so how we will change the limits? That's a good question. So we will do this. Let me change the color. Yeah, this is. So we will do this, that we will differentiate this. DOOMG. This is the same color, sorry. Yeah, I'm using this color. dA over d theta. So if we differentiate this, so it will become minus a. Okay, currently I'm not going to change the limits. I will change the limits. This step will be to do this, as we have this function. So when we are writing a here, so our theta has been disappeared. So how we will deal with this theta? So currently I'm telling that, then I will be back for the limits. Okay, so this is our working currently. After this we will go for limits. Okay, if we differentiate dA upon pi minus theta, like dy over dx, so this will become minus 1. Okay, we have to replace d theta with the dA. Okay, so d theta will go there and it will be minus dA. Okay, so we are done with this. Let's talk about limits. Okay, oh, that is not my color. I will use this color. Sorry, it is a bit similar. Yeah, I think this will be very well. Limits. So as our function is a, now the new function is a is equal to pi minus theta. So wait for a bit. I have to look at one thing. Okay, so if we insert this pi in this, pi minus pi will give me a is equal to 0. So our first limit will be 0 and the second will be a is equal to pi minus theta, same. Okay, wait, a is equal to pi minus, the second limit is 0, so we will write 0 here. So we will see this, that a is equal to pi. So that's a coincidence that our limits didn't change. We again get those limits same, pi and 0. Okay, so let me show you what is our current function which we have to integrate. After substituting a, we have this negative a tan inverse a. Wait, one thing I forgot to write the limits. OMG. Erase it. I can write it again. It will take more time, I think so. So the limits will be same. We had showed that how they will be same, and instead of d theta we are writing dA. The question is here how this came. We got this as we had replaced negative dA instead of d theta. So instead of writing here, I write negative here. Okay, no problem. Yes. So now we will go for the by parts. Okay. So by now I'm doing by parts here. How to do by parts? That we have to know, and we had showed this. I think yes, we had showed the method of by part in our video of integration. So let's do the by parts. First of all, we have to recognize that what is u here. It is really significant to recognize what is u here. For this, there is something like I think I had told you in the integration video. Let me confirm. No, but yeah, when we have any function and we have inverse in it, okay, so it will be u. It will always u. So this is u. Let me do now with blue. This is u and this is v prime. Okay, look at this. This is u and v prime. So u will be what function? Inverse function. And the second one will be v prime. So here is a, which is v prime. So let's go back with that. Okay, so I'm going to write here u is equal to tan inverse a. Okay, and if we have to differentiate this, okay, if we have to differentiate this, we have to know that the differentiation of this will be 1 upon 1 plus a square. Okay, and the second here is v prime is a. So to find v, we will integrate it. If we integrate it, the power will be plus 1 and it will divide with the new power. Okay, so currently we are on this point. Still we have a lot of working to do, but we are going very well. So I will again go through till there. We had recognized, we have analyzed that these are the properties which we will use. So we have to know these properties by heart before doing this question, and we discuss these properties in our video of integration. Okay, this is known by part method, okay, which we are using, and the second is simple integration. Okay, then we had replaced pi minus theta with a to simplify this function. Okay, then we had differentiated this we had differentiated this substitution. Okay, so we got what we have to write instead of d theta. Okay, then we had find out our new limits, but That the coincidence that those limits are still same for this after the substitution. Okay, then we write our new function after substitution. Okay, then we started doing by part method, and just we did that what is u prime, what is v prime, and what is v. Okay, we have to know that the differentiation of tan inverse a is 1 upon 1 plus a square, and we had look at in this also like this. Tan inverse pi minus theta, we can say this a 1 upon 1, 1 upon 1 plus a square, like 1 upon 1 plus pi minus theta whole square. Okay, so let's moving ahead. If you look at v prime, so it is equal to vu. Okay, we will write tan inverse a v multiplied by u, a square upon 2 multiplying with a square upon 2, okay, minus u prime integral u prime is 1 upon 1 plus a square and then there is multiplying with v is a. Okay, so this is a square upon 2 is v. Okay, so here we will write a square upon 2 tan inverse a. we didn't did nothing. Okay, just we had write this in starting to simplify this to have a better version of this. Then integral. Now 1 minute before integral, I will take this 2 out of the integral as it is constant, minus 1 upon 2 integral. Then I am multiplying this a square with this a square divided by 1 plus a square. Okay, we are okay till this, nothing problem. Then what we will do, that's a question. So to integrate this, we want it in a form that we can integrate it, because currently a square upon 1 plus a square we can't integrate. So we will change this form using partial fraction or anything. Okay, so what we will do, that's a question. So we can do this, that I have a plan how to do this. So I am again changing color. I'm going with this color. There are multicolors in this part. Okay, so a square divided by 1 plus a square. Okay, so we are trying to form anything in numerator like this. Okay, so I will write a square plus 1. So these are same, but the point is when we are adding 1, so we have to subtract 1 also. So we are subtracting 1 also. Then here is a square plus 1. Now let me tell you, and if we write this 5 upon 3 upon 2, sorry, upon 2, it is equal to 8 upon 2, which is 4. Okay, and what if I write 5 upon 2 plus 3 upon 2, 3 upon 2, what it will be? It will be 2.5 plus 1.5, which is also 4. Okay, so are you getting this? So now we will do this, that we will write a square plus 1 upon a square plus 1 minus 1 upon a square plus 1. Okay, so this become 1 minus 1 upon a square plus 1. Okay, we are done till this. So currently we will go back to our function where we had left with blue. So it will become a square upon 2 tan inverse a minus 1 upon 2 integral 1 minus 1 upon a square plus 1, which I can write it as 1 plus a square. Okay, just have a good look, nothing. I will tell why. Because we had learned, I will tell what we had learned. Okay, moving ahead. Just don't break the rhythm. Now I will tell in this step what we had learned. So this is same a square upon 2 tan inverse a minus 1 upon 2. Now we are going to integrate this. Modulus integration of 1 is a minus integration of this will be, what will be its integration? Yeah, we had learned the differentiation for this. Let me show you that we had differentiated this. So now we are going back this. Okay, we are currently on this position and we are integrating it, so we are going to tan inverse a. So that's why I just simplified that. Tan inverse a okay, so we will do this. We are on a very well position. We had completely integrated our function. Now just we have to do our last step, because as we have limits 0 and pi. Just now I have to apply the limits. Okay, so let's write what is our limits. 0, sorry, pi will be upper limit and this is 0. Okay, so right here pi square upon 2 tan inverse pi minus 1 upon 2 pi minus tan inverse pi okay. Then our second limit is, we will subtract our second limit minus sign here. Then second limit is 0, so 0 square upon 2 tan inverse 0 minus 1 upon 2 0 minus tan inverse 0. I am not asking you to find out the exact form, just go with the decimal value. Okay, so let's calculate. This will become 0, yeah. So if I talk about pi square upon 2 tan inverse pi minus 1 upon 2 pi minus tan inverse pi. Okay, then subtract. Before subtraction, I can write what is the decimal value for this. The decimal value for this is 5.29. Then we have this remaining. I think this will be 0. Let me confirm it. Yeah, it is looking like a 0. So it is 0. So we got 5.29. So we can write it as 5.3. So this is our answer. So let's have a look on our working. First we had revised that what are the properties of integration which will be used in this part. The first thing we had used by part method, and the second, the property of integration, which is 1 upon 1 plus x square will be, after integration, will be tan inverse x. Okay, then we had substitute pi minus theta with a, then we differentiated that a, so it become minus 1, and we got, instead of d theta, we got negative dA. Okay, then we had changed the limits. There was a coincidence that we got the same limits. Then we write our simplified form, and then we started our by part method by analyzing what is u, what is v prime, what is u prime, what is v. Okay, then we just put those u, v, and each and everything in our formula which we had memorized through by part method. Then we got a form of a square divided by 1 plus a square. We can't integrate it, so we go for the to get them in two parts which we can integrate. So we decided to get a thing in the form of denominator, so we added a square with 1 and subtracted with minus 1. So we had divided them in two parts, a square plus 1 upon a square plus 1 minus 1 upon a square plus 1. The a square plus 1 upon a square plus 1 become 1, which is okay, and the second thing is was become minus 1 upon a square plus 1. Okay, then we integrated 1, which is simply a, and if we integrate minus 1 upon a square plus 1 was minus tan inverse a. Okay, then we applied limits on the whole thing which we got after by part method, and through that we got the answer 5.3. So that is our final answer which we had got through this lengthy working. Hope you got the idea of this question. Okay, so thanks for watching the video. We will be back with another video soon.